Hi guys, so today we're going to be looking at Chapter 8, Section 3, Analyzing Geometric Sequences and Series. So we're going to start off with looking at the geometric sequence. It's the ratio of any term in a previous term that is constant. So the constant ratio is also called the common ratio and is denoted by R. So we're going to be using R instead of that notation N instead. If I were to look at the first sequence that's given to us, I could start off first by trying to identify, is there a number that can multiply or divide into 6 and 2, or 6 and 12. Seems like it's multiplying by 2, but if you notice here, we can't do the same. It's not like we can multiply 2 to every single term. So this would be considered not a geometric sequence. Okay. If I were to look at the next one, we have here 2 going to 4, which is multiplying by 2. 4 going to 8, multiplying by 2. Again, multiplying by 2, and the last one is multiplying by 2. So because we have a constant ratio, multiplying by 2, automatically I could say that this is a geometric sequence. The last one is a little bit different. As you could tell, if we were to go this way, in this direction, you could see that we're all multiplying by 4. But whenever we're trying to find the difference between two numbers, we always want to go left to right. Left to right, left to right, and left to right. So in this case, it's better to just write it as a ratio. Let's start off with 64 over 256. If I were to divide both of them by 64, you would get your answer, which is 1 over 4. And so instead, we could just write it as they're multiplying by 1 over 4. Same thing goes with 16 to 64. Again, 16 is on top, 64 is on the bottom. If I were to simplify it, let's see if we get the same ratio. And we get 1 over 4. Cool. So it seems like all of them are just multiplying by 1 over 4. And since it's the same ratio, again, we would say that this is a geometric series. Okay. Alright, so writing rules for geometric sequences. We have the formula an equals to the first term times the ratio to the power of n minus 1. So if we're asked here to write the rule of the nth term for the following sequence, and then afterwards find the 8th term, I'm going to start off first by finding out what the ratio is between every single term. Looks like we're all multiplying by 3. So our ratio would equal to 3. Our first term is going to be 5. And that's all we really need to write down our formula. We have here an equals to the first term times the ratio to the power of n minus 1. If I substitute it in, we get an equals to 5 times 3 to the power of n minus 1. And that's all we could do. That would be the end of our formula. So now if we're trying to find the 8th term, all I'm going to do, substitute n for 8 and see what our value becomes. If I have here 8 minus 1, that equals to 15 or 5 times 3 to the power of 7, which equals to 10,935. And that would be my final answer. Alright, next problem. Let's say instead we're not given the first term. Instead we are given one of the following terms, the 4th term of the sequence, and its ratio. So I'll write right here that we have the 4th term. And if we know the 4th term is supposed to equal to 12, we also know that our n is also going to equal to 4. our ratio is 2, which is already given. And so what we need to identify is our first term. So here we have our formula. And again, I want to identify what my first term is. I'm going to plug in the 12 for an. If we're looking at the fourth term, that also means that I'm plugging in the 2 for the r, and fourth term, so that means that our n value is going to be 4. So this equals to a first term to 2 to the power 3, which would be 12 equaling to 8a. Divide 8 to both sides. And we get our final answer, 1.5, as our first term. After we find out what our first term is, and we already know what our ratio is, then all I need to do is plot them all into the formula. an equaling to 1.5 times 2 to the power of n minus 1. And that's my final answer. Okay, last problem. So let's say instead you don't even have the ratio, you're just given the second term and you're given the fifth term of the sequence, and we want to write a rule for the nth term. So just like last time with arithmetic sequence, we want to start off with taking out the information that we have. If we're looking at the second term, that means that our n here is equal to 2. And so if I were to rewrite it in an, with the first term multiplying with n minus 1, then my new equation would be I would take the 12. 12 equals to a1, our r we don't know, and we do know our n, which is 2 minus 1. So we do have here a1 r to the power of 1, which is just 12 equaling to a1, our first term, times r. We also know what our fifth term was. So for our fifth term, we have here a5 equals negative 768. So this was supposed to be when n equals to 5. And we get here negative 768 equaling to the first term times r to the power of 5 minus 1. And from here we get negative 760, that's supposed to be 8. Negative 768 equals to a1 times r to the power of 4. And that's all we can do. So based off of this, rather than using the elimination method like we did with arithmetic series, I want to start off first by getting rid of the a1 and moving it to the other side so that I can have it where r is equal to whatever. Or actually, yeah, I will move the r to the other side because that would make it easier and I can cancel out my r to the power of 4. So instead, right here, take the r, divide it to both sides. If I do that, I'm left with 12 over r equaling to a1. And then from here, I could substitute the a1 for 12 over r. So I get negative 768 equaling to 12 over r times r to the power 4. Then I can cancel out the r's, and I'll be left with negative 768 equaling to 12 r to the power 3. Then last step, divide 12 to both sides. That leaves me with negative 64 equaling to r to the power 3. Last thing to do will just be to cube root to both sides to get rid of the r to the power of 3. When I do that, I get left with negative 4 equals to r. And now we have our r value. Last thing we need is still our a1 value. So I will take my original equation, or at least one of them, and I'll take this one because it's the easier one. And I'll substitute the r for -4. If I do that, divide -4 to both sides, that equals to -3 equals to a1. And so I have my first term, I have my ratio. Now I can write down my equation, which is going to be an equaling to -3 times -4 to the power of n minus 1. That would be my final answer in the end. Okay. So hopefully this helped. Good luck.